We will start today with this property which is called ionization enthalpy. See, the first ionization enthalpy of transition elements are higher than those of S block element. I thought we have already discussed this point when I said in the periodic table atomic or ionic radii, or whenever you try to move from left to right in the periodic table, when you try to move from left to right in the periodic table, you will see that the first one is nothing but it is the S block element, then we have the P block element, then we have the then we have the D block element, and then of course the P block element. So first is S block element, then D block, and then P block. So when you are moving from left to right, the atomic and ionic radii decreases. So when the atomic or ionic radii decreases, that means ionization energy also ionization energy will increase. What I mean to tell you is the ionization energy of P block will be the maximum in the periodic table, followed by D block. Of course, since D block is in between P and S, so the D block ionization enthalpy will be intermediate between S and P block, and the least is nothing but of S block element, because even they are the best reducing agents. S block element are the best reducing agent with maximum E naught values. So let's start first with the 3D series. See, when I am talking about 3D series, as I have already told you, atomic or ionic radii does not follow a regular trend. So the point is, will the ionization energy follow a regular trend? Answer is no. Ionization energy will also not follow a regular trend. The reason behind this is because although the atomic and ionic radii is following a very irregular trend, first decreases, then become constant, then increases. But there is also one point, and that is there is a concept of half filled and fully filled electronic configuration. Chromium, atomic number 24, has a half filled, while copper has a fully filled electronic configuration and 3D series. That's why ionization energy does not follow a regular trend whenever we try to move from left to right in 3D series. So I have written the first ionization enthalpy of transition elements are higher than those of S block element but lower than P block element. In particular, transition series ionization enthalpy increases gradually with increase in atomic number. Although, as I said, there are some irregularities. Those irregularities are because of what? Number one, electrons are always being added into the what? Penultimate shell. That means, if I am not wrong, when I am talking about the transition elements, the electrons are always being added into the penultimate shell. What I mean to tell you right now here is that in case if the electron is added into the penultimate shell, that means if this is the nucleus, this is your penultimate shell, that is 3D, and then 4s. This is 4s and this is 3D. Since increase in nuclear charge will increase what? Increase in nuclear charge will increase the nuclear charge will increase, or atomic number increases the nuclear charge, but the shielding effect of 3D orbital is very poor. So that means the electron will be strongly pulled towards us. The atomic or the ionic radii decreases in the beginning. That is what I said. And since the screening effect is not able to counterbalance in the beginning, so that's why, as usual, it follows an irregular trend. The irregular variation of first and second ionization energy in 3D series is varying due to the stability of different oxidation state. As I said, when I am talking about chromium, chromium has a low first ionization enthalpy, because if you write down the electronic configuration of chromium, it is this: argon 18 and 3d5 and 4s1. So if I'll remove this first electron, so first ionization energy will have a low value. The reason is because once it will lose this 4s1 or 4s electron, it will reach to a half filled d orbital configuration, and that's why it has a higher stability. While if I'm talking about zinc, zinc has a very high first ionization enthalpy because the electron has to be removed from the 4s which is already filled and 3d10. So that's why it is very difficult to pull out an electron in case of zinc. But the point right now is, when I'll try to travel from 3D to 4D, 4D to 5D, since it is going away from the nucleus, this is 3D, this is 4D, and this is 5D. As you try to move away from the nucleus, what will happen? The removal of electron will be easier, and that's why we always say that the atomic and ionic radii increases, so ionization energy will decrease down the group whenever you go from 3D to 4D, 4D to 5D. Although 4D and 5D has almost the same ionization energy, I have already told you about the concept of inert, uh, about lengthenite contraction. So 5D का lengthenite contraction जो है बहुत ज़्यादा होता है because of 4F subshell being started to fill up, of course in 4D also, but the poor shielding effect of 4F and 5F subshell make the lengthenite contraction, and that's why 5F 5D will have the highest, I will say, right, ionization energy. Now, as I said, ionization energy is also used in order to decide the stability of an oxidation state. So एक बहुत सिंपल सा कॉन्सेप्ट मैंने डिस्कस किया था, nickel can readily lose two electrons to become nickel 2 positive because the sum of two ionization energy has a low value. So thermodynamically, nickel is always stable in plus 2 oxidation state. I repeat, nickel is always stable in plus 2 oxidation state. The reason is because the sum of two ionization energy for nickel has a very low value. Of course, I'm comparing it with platinum. If you try to see nickel की value 2490 और platinum की 2660 है, तो nickel की conversion nickel to positive is quite easier in comparison to platinum because platinum cannot lose, or it has a higher ionization energy in comparison to that of nickel. But the point right now is, if we compare the sum of the ionization energy of platinum, the sum of 4 ionization energy of platinum has a very low value. That means if I am talking about platinum, the value is nothing but it is how much? 9360. This is the sum of 4 ionization energy for platinum, which is of course very low in comparison to that of what? Nickel. So can I say platinum is stable in plus 4 oxidation state? The sum of 4 ionization energy of platinum has a lower value. This question can be framed in another way, and that is K2PtCl6 is known, but K2NiCl6 is unknown. So as I said, if you calculate the oxidation number, अगर आप इसे split up करोगे, twice of K positive plus PtCl6 2 minus, so X plus 6 into minus 1 is equal to minus 2. X is plus 4. So from here we conclude that platinum has a plus 4 oxidation state. Similarly, nickel also will have a plus 4 oxidation state over here. But conversion of nickel to positive is easy. But platinum is nickel is very difficult. So that's why this compound is known to us and this is unknown. So this is the concept of your significance of ionization enthalpy and oxidation status. हमारा नेक्स्ट टॉपिक है इलेक्ट्रोड पोटेंशियल एंड रिड्यूसिंग करेक्टर. Again, a very very important topic because from last 3 to 4 years the question is actually being asked from electrode potential, and of course it is on the basis of reducing tendency also. See, I have already told you when I was teaching you the concept of ionization energy, मैंने आपको एक बात बोली थी, and that was the E naught value, right? and of course the ionization energy depend directly or indirectly upon the atomic radii. Now what I was trying to tell you is, point number 1, if I am talking about 3D series, the E naught value in any case depend upon three things. One is called as hydration energy, of course ionization energy, and one is called atomization or dissociation energy. Dissociation or atomization. So as I said, it is actually, or E naught value is dependent on ionization energy. Since ionization energy depend upon atomic radii, and as atomic radii do not follow a regular trend, so that means E naught value will not follow any regular trend. I repeat, electrode potential depend upon hydration energy, ionization energy, dissociation or atomization. Ionization energy directly or indirectly depend upon atomic radii. Since atomic radii do not follow a regular trend, so that means ionization energy as well as the electrode potential will also do not follow a regular trend. This is what we have already done. Now, I have already told you what is electrode potential. So I don't have to go into the detail of what electrode potential is. We have done it in electrochemistry, that it is basically the potential which is developed whenever an electrode is actually being put in any solution, right? So what is the potential difference that is being set up? That's called electrode potential. As I said right now, the irregularity of E naught values explain on the basis of ionization energy, sublimation enthalpy, or whatever. You can see in the 3D series, I just now told you S block elements are very good reducing agents. That means they have the maximum E naught value which is negative. डी ब्लॉक एलिमेंट्स की अगर हम बात करें तो ई नॉट वैल्यू जो होती है वो नेगेटिव होगी, बट कंपैरेटिवली लेस नेगेटिव इन कंपैरिजन टू दैट ऑफ एस ब्लॉक एलिमेंट. बट अगर मैं बात करूं पी ब्लॉक एलिमेंट्स की ई नॉट वैल्यू पॉजिटिव होती है, बिकॉज दे आर नॉट गुड रिड्यूसिंग एजेंट, दे आर गुड ऑक्सीडाइजिंग एजेंट. नाउ when you try to study the trend, which as I said is the most important, you talk about 3D. 3D में जो सबसे इंपॉर्टेंट चीज चल रही है वो है टाइटेनियम, वेनेडियम, क्रोमियम, मैंगनीज, आयरन, कोबाल्ट, निकल, कॉपर, जिंक. आप बहुत ध्यान से अगर देखेंगे तो ऑल ऑफ देम हैव द नेगेटिव ई नॉट वैल्यू एक्सेप्ट कॉपर. द कॉपर हैज ई नॉट वैल्यू पॉजिटिव. This is the most important question that we are going to discuss today. So let us start. Point number A. Electrode potential is used to decide the stability of oxidation state in solution. Remember, lower the electrode potential. That means more negative the standard reduction potential of the electrode, more stable is the oxidation state of any transition metal. Of course, in aqueous solution. That means more the negative value of this, greater will be the stability of the oxidation state. And of course, lesser the negative value, lesser will be the stability of the oxidation state in, of course, ions. Now, as I said, all the elements of 3D series are very good reducing agents except copper, which has E naught value 0.34. However, as I said, they are less or weaker reducing agent in comparison to S block. I have already cleared these 2 points. Now, I am going to the most important point right now. If I am talking about Mn, if I am talking about nickel, and if I am talking about zinc, the more negative E naught value of Mn is because it has a half filled d orbital. That means if I am talking about Mn2 positive, Mn2 positive has a half filled d orbital configuration or half filled configuration, and because of this half filled configuration of Mn, it has a negative value of E naught. When I am talking about zinc, right? Zinc has a 3D10 configuration. Again, fully filled configuration. That's why the E naught values are negative. There is one point which is nickel. Nickel has D8 configuration. and its E naught value is negative because of enthalpy of hydration. So nickel has a very high enthalpy of hydration. Because of that, its E naught value is negative. Now we will be discussing one by one the questions which are very, very important, right? And before that, I must take up the stability of oxidation state. और उस स्टेबिलिटी ऑफ ऑक्सीडेशन स्टेट में भी एक बहुत इंपॉर्टेंट चीज अभी आने वाली है, और वो है, मैंने जो आपको ऑलरेडी बताया हुआ है, लास्ट ईयर भी बताया था, इस साल फिर आपको मैं बता रहा हूं, ट्रांजिशन एलिमेंट में अगर हम बात करें, आपको याद होगा दिस इज डी सबशेल, एंड डी सबशेल हैज गॉट 5 ऑर्बिटल्स, एंड ये जो 5 ऑर्बिटल होते थे वो होता था डी एक्स वाई, डी एक्स जेड, डी वाई जेड, इनको हम बोलते थे टी टू जी, और डी एक्स स्क्वायर माइनस वाई स्क्वायर और डी जेड स्क्वायर को हम बोलते थे ई जी ऑर्बिटल. नाउ I am going to first take up the case of manganese. Manganese atomic number 25 है. If I'll write down the electronic configuration, it is argon 3d5 and 4s2. So manganese quickly has a tendency to lose 2 electrons to become Mn2 plus. When I am talking about Mn2 plus, it has now become the configuration argon and 3d5, which has a stable half-filled configuration. I said it has a stable half-filled configuration. Half-filled configuration. And it is because of this, manganese is always stable in +2 oxidation state. And although if I'll ask you, is it possible that manganese can go into Mn3 plus? Answer is no. If I'll write down the configuration, it is argon 3d4. The conversion of manganese 2 to manganese 3 is not at all possible or is difficult because it is already attaining the stable half-filled configuration in +2. Now let's talk about iron. Iron is atomic number 26. So configuration is argon 3d6 and 4s2. Iron exists in 2 variable oxidation state. One of them is of course +2. So if I am talking about iron in +2 oxidation state, the configuration will be argon and of course 3d6, where I'm going to lose 2 electrons from this s orbital and I'm getting Fe2 plus, which is called ferrous. Ferrous is green in color. Remember, I said ferrous is always green in color. So this is ferrous, which is green in color. But iron is always oxidation stable in +3 oxidation state. It will lose another electron to become Fe3 plus, because it has again 3d5, which is brown in color. This is ferric. Ferric is brown in color. And it has a again same answer, stable half-filled configuration. I repeat, iron has a stable half-filled configuration, and that's why, so iron is stable in, again it is stable half-filled configuration, that is same. So we conclude from here 2 things. Number 1, Rn is always stable in +3, while Mn is always stable in +2 oxidation state because they have half-filled configuration. Now in the same way, if I'll take up chromium, the most important, if I'll write down the configuration of chromium, chromium is nothing but it is the configuration of chromium. Chromium is 24. So if I write down the configuration, it is argon 3d5 and 4s1. Chromium is always stable in +3 oxidation state. The reason now is it has a half-filled T2G orbital configuration. I repeat, you may ask me, sir, how do you reach? It is because अगर हम क्रोमियम के कंपाउंड लैब में भी देखेंगे, they are always stable in +3 oxidation state, and we always used to say क्रोमियम कभी भी +3 में इसलिए स्टेबल होता है बिकॉज उसके पास हाफ फिल्ड T2G ऑर्बिटल, यानी T2G3, जो अभी मैंने आपको बताया था कि T2G ऑर्बिटल, अगर ये डी जनरेटेड ऑर्बिटल्स थे ये, तो इसमें 1 2 3. This is called T2G. T2G. So it has a half filled T2G orbital configuration. T2G. T2G3. So since chromium is always stable in +3 oxidation state due to half filled T2G orbital configuration. T2G orbital configuration. So it won't be converted into any other higher or into the lower oxidation state. Now the most important, I was talking about copper. जिस कॉपर की मैं बात कर रहा था उसमें एक और बड़ा जबरदस्त एक्सेप्शन है जिसे हम अभी स्टडी करेंगे. कॉपर का एटॉमिक नंबर 29 होता है. तो इफ आई राइट डाउन द कॉन्फ़िगरेशन, इट इज आर्गन 3d10 एंड 4s1. जो सबसे इंपॉर्टेंट चीज यहां पर है, दैट इज, if I'll ask you, copper exists in again two oxidation state. One is called cuprous and another is called cupric. This is lower oxidation state, always end with cuprous, OUS. So if I'll lose one electron from here, it become argon 3d10, which is fully filled configuration. This is fully filled configuration. Fully filled configuration. But the point right now here is कि अगर ये फुली फिल्ड कॉन्फ़िगरेशन है तो इसे तो बहुत ज्यादा स्टेबल होना चाहिए. बट कॉपर इज नेवर स्टेबल इन +1 ऑक्सीडेशन स्टेट इन एक्वस मीडियम. इट हैज अ टेंडेंसी, और आपने वैसे भी अभी इसकी ई नॉट वैल्यू देखी, +0.34 थी. तो प्लस का मतलब इट इज नेवर स्टेबल इन +1 oxidation state in aqueous state. It will be converted into +2 oxidation state, and that is argon 18 3d9. ऑल्दो आपके दिमाग में जो क्वेश्चन आ रहा होगा वो ये है कि सर, ऑल्दो ये फुली फिल्ड इलेक्ट्रॉनिक कॉन्फ़िगरेशन में है, देन हाउ इट इज पॉसिबल दैट कॉपर कैन बी कन्वर्टेड इनटू कॉपर टू पॉजिटिव. सर यहां तो बहुत हाई आयनाइजेशन एनर्जी लगेगी, क्योंकि देखो अगर ये फुली फिल्ड है तो यहां तो वेरी हाई आयनाइजेशन एनर्जी, वेरी हाई आयोनाइजेशन एंथैल्पी is required to convert, ionization enthalpy is required to convert copper 1 into copper 2, right? The most important. But the point here is the copper 2 positive has a very high hydration enthalpy. इसकी hydration enthalpy इतनी high होती है कि वो इस ionization energy को भी compensate कर देती है. So we will take up now the question on the basis of this. Number one, the question number one which I'm going to take up right now is the high E naught. मैंने अभी बोला है Mn3 positive Mn2 positive में convert होगा. Mn3 positive can be easily converted into Mn2 positive. Decrease in oxidation number is called reduction, और जिसकी reduction होती है वो होता है good oxidizing agent. Good oxidizing agent मतलब इसकी E naught value होगी positive. The low value, so that's why I've written high E naught value. That means E naught value will be positive. The low E naught value of 3 to 2, iron is always stable in +3 oxidation state. So it never goes into this. ये नहीं जाएगा तो E naught value negative होगी. Similarly, vanadium is also stable in +3 oxidation state, so it never goes into +2. E naught value is negative. As I said, the low value of E naught, again Cr3 positive Cr2 positive में नहीं जाएगा, because chromium is again stable in which oxidation state? +3, because of half filled T2G orbital configuration, as I have written here also, half filled T2G orbital configuration. That's why E naught value is again negative. Cr2 positive and Mn3 positive. Cr2 positive and Mn3 positive both are in D4 configuration. The E naught value of Cr3 to Cr2 is minus. The reason is it is not going from 3 to 2, because chromium is always stable in +3 oxidation state due to half filled T2G orbital configuration. मगर Mn3 Mn2 में जाएगा. Exactly, the reason is because Mn कभी भी +2 oxidation state में stable होता है half filled configuration की वजह से, और इसीलिए अगर ये 3 से 2 में जा रहा है, डिक्रीज इन ऑक्सीडेशन नंबर इज कॉल्ड रिडक्शन, और जिसकी रिडक्शन होती है वो होता है गुड ऑक्सीडाइजिंग एजेंट. जो मैंने यहां पर भी एक्सप्लेन किया, तो वैल्यू प्लस में आएगी, ई नॉट वैल्यू विल बी इन पॉजिटिव. नाउ द नेक्स्ट एंड द मोस्ट इंपॉर्टेंट पॉइंट विच आई वॉज टॉकिंग अबाउट इज कॉपर की ई नॉट वैल्यू क्यों पॉजिटिव होती है. कॉपर की ई नॉट वैल्यू इसलिए भी पॉजिटिव होती है, उससे यह भी पता चलता है कि इट इज नॉट गोइंग टू लिबरेट हाइड्रोजन गैस फ्रॉम द एसिड. वो आपने रिएक्टिविटी सीरीज में भी देखा हुआ है. नीड नॉट टू टेल यू दैट रिएक्टिविटी सीरीज में कॉपर जो होता है वो हाइड्रोजन के नीचे होता है. दैट इज क्लियर. द पॉजिटिव ई नॉट वैल्यू, दैट इज द मोस्ट इंपॉर्टेंट थिंग. व्हाई द ई नॉट वैल्यू ऑफ कॉपर इज पॉजिटिव? We will be discussing this question right now. The reason is the sum of the enthalpy of sublimation and ionization energy is not balanced by the hydration enthalpy. That we'll take up. But the most important question right now is copper 1 is unstable in water and has a tendency to disproportionate. हमने इलेक्ट्रोकेमिस्ट्री में भी एक क्वेश्चन किया था, कॉपर वन रिएक्ट करके या डिस्प्रोपोर्शनेट करके कॉपर 2 पॉजिटिव और कॉपर इन सॉलिड देता था, अगर आपको याद हो. और उसका रीजन है ये कि कॉपर 1 has a tendency to disproportionate to give copper 2 positive and copper. The reason I told you is because copper 2 positive has a very high or more negative enthalpy of hydration. That's why copper 1 has a tendency to get converted into copper 2 positive in aqueous medium. That's the most important reason. Again, I'll repeat. Copper 1 has a tendency to disproportionate in aqueous medium and is get converted into copper 2 positive whose hydration enthalpy has a very high or more negative enthalpy of hydration. अगर आप मुझसे पूछोगे कॉपर 2 पॉजिटिव की हाइड्रेशन एंथैल्पी क्यों हाई होती है, बिकॉज द साइज इज स्मॉलर in comparison to copper 1. That's why. So this is another reason. Now we have already done these questions. Why do second and third transition energy elements have same? Because of length and contraction. This also we have done. So ये वाला क्वेश्चन हम कर चुके हैं. ये वाला क्वेश्चन भी हम कर चुके हैं. Why nickel second while platinum are more stable. ये वाला क्वेश्चन भी हम कर चुके हैं. How will you account for the variation of ionization enthalpy? Why does it follow an irregular trend? The reason I told you, because it depend upon what size and ionization energy, which do not follow a regular trend. Then this question also we have done. Why Cr2 positive and Mn3 positive, although are both in D4 configuration, we have done this question. Then why are Mn2 positive compounds more stable than Fe? This also we have done. ये तो ऑलरेडी स्टेबल है ही इस ऑक्सीडेशन स्टेट में, ये 2 से 3 में जाएगा हाफ फील्ड की वजह से. बट जो सबसे इंपॉर्टेंट क्वेश्चन है वो ये है जो मैं डिस्कस करने जा रहा हूं कि ई नॉट वैल्यू ऑफ कॉपर 0.34 क्यों होती है. As I said, the E naught value depend upon three things, and that was H, I, A. You can call it as atomization, you can call it as dissociation, one and only the same thing. Now, E naught value of copper is 0.34. The reason is very simple, because if I write down the equation, M in solid, atomization goes into gaseous, because atomization matlab copper goes to gaseous state. Then gaseous state say it is going to convert it by ionization energy into copper 2 plus. But this process is very difficult to be carried out because copper 2 plus में D9 configuration में होता है. But as I said, since I have written here, copper has a high value of atomization. यहां ये भी बहुत हाई होती है. Low enthalpy of hydration. Also, the transformation of copper to copper is not balanced by enthalpy of hydration, makes the value positive. मैंने बोला ये भी बहुत डिफिकल्ट प्रोसेस है, ये भी बहुत डिफिकल्ट है. बट M2 पॉजिटिव जैसे ही हाइड्रेशन या हाइड्रेटेड होता है, ह्यूज अमाउंट ऑफ एनर्जी इज रिलीज्ड. बट द पॉइंट हियर इज the transformation is not balanced by the enthalpy of hydration. That's why the E naught value become what? Positive. So this is the reason you have to write down copper has a very high enthalpy of atomization and low enthalpy of hydration, but it is not balanced by the enthalpy of hydration, which make the E naught value positive. We have already done this question. ये वाला example 8.7 we have already done. 3 to 2 में जाएगा. Exactly. Look, decrease in oxidation number is called रिडक्शन, और जिसकी रिडक्शन होती है उसकी वैल्यू जो होती है वो पॉजिटिव होती है, बट ये इसमें नहीं जाएगा नेगेटिव वैल्यू, और आयरन भी इसमें नहीं जाएगा, दिस आई हैव ऑलरेडी एक्सप्लेन, राइट। सिमिलरली क्रोमियम का भी मैं कॉन्सेप्ट आपको बता चुका हूं, सो आई डोंट हैव टू टेक अप दीज ऑल क्वेश्चंस, यहां तक मैंने सब कुछ आपको करा दिया है।